Quantitative ability problems on chain rule. In the problems of chain rule, we come across two proportion. One is called direct proportion and second is called inverse proportion. What examples we can take for direct proportion? Number one, men and work are directly proportional. More the men, more will be the output work produced. Time and work are directly proportional. More time we will allocate, there will be more work output. Cost and number of items are directly proportional. More the cost we are ready to pay, more number of items can be purchased. So these are the examples of direct proportion. And whenever these variables are in direct proportion, they can be written on either side of equal to. Now, what examples can be quoted for inverse proportion? Men and time are inversely proportional. More the number of men, less time is required to finish the work. Speed and time are inversely proportional. More will be the speed of driving, less time is required to cover the distance. Men and days of food provision are inversely proportional. More the number of men, the same food will last for less number of days, or less the number of men, the same food will last for more number of days. So whenever the variables are in inverse proportion, they should be written on same side of equal to. Let's start with problem number 1. If 4 liters of oil is sufficient to light 80 lamps simultaneously for 5 hours, then 6 liters of oil can light how many lamps simultaneously for 8 hours? Now let us understand the proportions here. The quantity of oil and lamps are directly proportional. More the oil, more number of lamps we can light. Also, quantity of oil and hours are directly proportional. More the quantity of oil available, more number of hours we can light those lamps. So how the first equation will be? Obviously, the first equation can be written like this. As oil and lamps are directly proportional, written on either side of equal to. Even oil and hours are directly proportional, so written on either side of equal to. This is your equation number 1. The second equation can be written in a similar way, as 6 liters of oil is equal to X number of lamps for 8 hours. Now, how to further simplify these equations? I will write as oil required to light 1 lamp for 1 hour. These are 80 lamps for 5 hours. So 1 lamp for 1 hour, if I want, I should take this 80 and 5 in the denominator below 4 liters of oil. So this much liters of oil is required to lamp 1 light for 1 hour. Now, in a similar way, second equation can be written as oil required to light 1 lamp for 1 hour equal to 6 divided by X into 8. Now we can very well equate equation 1 and equation 2 like this, and the unknown variable X can be found out. X comes out to be 75. So with 6 liters of oil, we can light 75 lamps for 8 hours. Problem number 2. 2 boilers of same capacity consume 100 kg of coal in 5 hours. If 2 more boilers of same capacity are installed, then 160 kg of coal will last for how many hours? Now you can pause this video and just think, what are direct variation variables here? And you can write the equation on the paper. Okay. Now the quantity of coal and number of boilers are directly proportional. More the quantity of coal available, more number of boilers we can run. Even the quantity of coal is directly proportional to the hours. More the quantity of coal available, more number of hours we can run the boilers. So how the first equation will be? Very much similar to the previous question. 100 kg coal equal to 2 boilers for 5 hours. Well, number of boilers and number of hours are inversely proportional. More the number of boilers, hence the number of hours for which they can run in the existing coal are inversely proportional. So they are written on same side of equal to. Now, in a similar way, the second equation can be made as 160 kg coal is equal to 4 boilers for X number of hours, like this. Now we can simplify both these equations as 1 kg, 1 boiler for 1 hour will consume how much kg of coal? Here it is said 2 boilers for 5 hours consume 100 kg of coal. So 1 boiler in 1 hour will consume how much kg of coal? For that, this 2 and this 5 we should take in the denominator below 100 kg of coal, like this. Coal required to run 1 boiler for 1 hour is equal to 100 divided by 2 into 5 kg. In a similar fashion, the second equation can be written as coal required to run 1 boiler for 1 hour equal to 160 divided by 4 into x. As the left hand side of both the equation is same, we can equate their right hand sides. So after equating equation 1 and 2 like this, we can determine the value of x, which will come out to be 4 hours. Option A. Problem number 3. If 20 men can build wall 160-meter long in 10 days working 8 hours a day, what length of a similar wall can be built by 25 men in 4 days working 4 hours a day? Now here you should consider what are the direct proportion variable and what are the inverse proportion variable. Obviously wall and men are directly proportional, wall and days are directly proportional, even wall and hours are directly proportional, hence should be written on either side of equal to, like this. As I said, more the men, more length of wall can be constructed. More the number of days we give, more length of wall can be built. Even more hours if we allocate, more length of wall can be constructed. So 160 is directly related with 20, 10 and 8 hours, hence written on either side of equal to. So this is the input required to construct 160 meter of wall. 20 men, 10 days, 8 hours. Now what length of wall can be constructed if there is only one man working for 1 day and for 1 hour? For that, we should bring down this 20, 10 and 8 below 160 in the denominator, and that is equal to 1/10 meter of wall. So one man working for 1 day and that too for 1 hour can construct 1/10 meter of wall. Now the question is, what length of the similar wall can be built by 25 men in 4 days and in 4 hours? So now it is very simple. We should multiply this 1/10 meter of wall with 25, 4 and 4 further, like this. Length of wall constructed by 25 men working for 4 hours a day in 4 days equal to 1/10 into 25 into 4 into 4. That is equal to 40 meter length of wall. Option A. Problem number 4. An air pump fills 40% of air in a hot air balloon in 10 minutes. In how much time such 5 hot air balloons can be filled by single air pump? Now in 10 minutes, 40% of the air is filled in the balloon. So how many minutes are required to fill 100% of the air? This value of x can be easily found out by cross multiplication, like this. X is equal to 100 multiplied by 10 divided by 40, which comes out to be 25 minutes. So 25 minutes are required to fill one air balloon completely. Now the question is, how much time 5 such hot air balloons can be filled by single air pump? So to fill one balloon, it requires 25 minutes. To fill 5 such balloons, how much time is required? So simply we need to multiply it by 5, which comes out to be 125 minutes, or so called 2 hours and 5 minutes. Problem number 5. A hostel of 630 boys has a provision for 24 days when the consumption is 2 kg per day per boy. For how many days are the provisions sufficient for 360 girls at the rate of 1.5 kg per day per girl? Now, first of all, we should think what is the quantity of food available there. If there are 630 boys and every boy is consuming 2 kg per day, in a day the consumption is 630 multiplied by 2. And if this is going to continue for 24 days, we should further multiply it by 24. That is the provision of food available in the hostel, like this. Now, instead of 630 boys, suppose there are 360 girls and every girl is consuming 1.5 kg per day. Then the provision will last for how many days? So second equation can be constructed like this. 360 girls are there. They are consuming for X number of days at the rate of 1.5 kg per day per girl. As the right hand side of both the equation is same, we can equate their left hand sides like this. And we can determine the value of X, which will come out to be 56 days. Problem number 6. There is a provision for a garrison of 500 men for 40 days. After some days, 200 men left the garrison. If the entire provision lasted 60 days, after how many days did 200 men leave? Let us assume that this 200 men leave after X number of days. Okay. Now think how much is the provision of food available. 500 men can consume it for 40 days. So number of men multiplied by number of days will give you the provision of food like this. This is your first equation. Now we are assuming that 200 men left after X days. So initially for first X number of days there were all 500 men. So the consumption that they have made is 500 multiplied by X like this. Now 200 men left after those X days. So how many are there now? 300 men are there. And for how many days they are consuming? 60 minus X days. Because in the problem it is mentioned that the entire provision lasted for 60 days. So 300 men are consuming for remaining 60 minus X days. And that is equal to the provision of food available. As the right hand side of both the equation is same, we can equate the left hand side. So it will be like this. That is 500 into X plus 300 into 60 minus X is equal to 500 into 40. Solving this, X will come out to be 10 days. It means 200 men left the garrison after 10 days. Option A. Problem number 7. In a dairy farm, 15 cows eat as much as 10 buffaloes. If 300 cows can consume certain quantity of grass in 15 days, then how many buffaloes can consume double the grass in 25 days? Now in this question, it is clearly mentioned that 15 cows eat as much as 10 buffaloes. So eating capacity wise, 15 cows are equal to 10 buffaloes. So we can write like this. 15 cows are equivalent to 10 buffaloes, or 3 cows are equivalent to 2 buffaloes. Now what is said in this question? 300 cows can consume the grass for 15 days. So what is the quantity of grass available? It is equal to number of cows multiplied by number of days for which they can consume. So that is equal to 300 cows multiplied by 15 days. Provision of food or provision of grass, you can say. Now the question is, how many buffaloes can consume double the grass in 25 days? Let us say there are X number of buffaloes. So the second equation will be X buffaloes multiplied by 25 days equal to 2 times the initial grass quantity. As it is said, double the grass here. So I will write 2 into the provision of grass which was originally there. Now here I will replace this grass with 300 cows into 15 days. So the equation can be further written as X buffaloes into 25 days is equal to 2 into 300 cows multiplied by 15 days. Now on this side of the equation there are buffaloes and on the other side there are cows, which will not work. So we should convert these cows to equivalent number of buffaloes. As 3 cows are equivalent to 2 buffaloes, so 300 cows will be equivalent to 200 buffaloes. So I can write this equation further as like this. Solving this, we can determine the value of X now, which will come out to be 400. Option D. Hope you understood the topic of chain rule. I request you to practice additional question from any of the aptitude book, which will give you further confidence. Thank you very much.